So my name's Ben. I'm an architect developer at Theodo, which is a startup that helps other startups launch digital products and larger companies to deliver digital products faster. As I was just saying, so digital products, so this is an example of a project I architected with Made.com. They're a large e-commerce startup in London that basically sells sofas online, and we rebuilt their website, their mobile app, and a touchscreen in-store experience. Our projects range from being more front-end leaning and more back-end leaning, and we're all full-stack engineers. And today I want to talk to you about a more back-end leaning project and some of the stuff we learned about security during that. My role at Theodo is working on client projects, but also doing open source and speaking at events like this. And recently I've been advocating serverless technologies, and I've launched a serverless transformation blog recently on Medium, so feel free to follow that, and there's an article related to this talk. We also have a serverless newsletter that goes out every week with the top 5 articles about serverless, and I'll show these links again at the end if anyone wants to scan them. And yeah, we're going to jump into security in Lambda. So if you just raise your hand if you've deployed a Lambda function. Awesome. And if you keep it raised if you're using it in production. Cool. So quite a big part of the room. I'm going to go through the intro quite quickly and we'll get to the details. But before we do dive in, what is serverless? Well, it means different things to different people. It's obviously a framework for doing serverless applications, but to me it's more of an architectural movement where developers send application code to their cloud provider and it's run in isolated containers with every detail about the operating system abstracted, allowing developers to build quicker. It's also the leveraging of cloud-native solutions. For example, instead of recoding user authentication, using a serverless solution like Cognito for user authentication, or outside of AWS using something like Okta. Why do people do serverless? Well, as a cost reduction, some of us might have read the Hacker News article recently, which maybe puts that in question, but in the right use case and done in the right way, it can be a huge cost saving. Some people are referring to it as no-ops. I don't think it's no-ops. I think it's a move to more DevOps. And ops, or if you do have ops experts in your company, coaching and empowering developers not to make mistakes with serverless and to move quicker and be empowered. It also allows developers to focus more on business logic. Because we're leveraging third-party solutions to do things like user authentication, and also we're not tied up with operating systems and complicated deployments, developers can focus on the business values for their company. It's also scalable from day one, and if we can make more efficient usage of servers and data centers, we could reduce the energy cost of the internet, which would be a massive win. The internet currently uses about the same amount of carbon dioxide as the aviation industry, and that's only going up. So yeah, serverless. Just one quick note, it's not just Lambda. Today we're focusing on Lambda, but serverless is Lambda for your compute, S3 for storage, DynamoDB as a serverless database, API gateway for routing and linking into authentication with Cognito, SQS, SNS, really any AWS service that's sort of not provisioned but is serverless. And this gives us great power and flexibility. But today we're focusing on functions as service and AWS Lambda, and I'm going to go through a set of key checkpoints to securing your AWS Lambdas. The first one is the Temp Directory. So the Temp Directory is the only place on a Lambda where you can write to disk. This is massively useful if you want to cache a database connection or instantiate the AWS SDK and not do that on every request. But it does remove the sandboxing of Lambdas. It's quite nice to think that a request comes in, it's run in a Lambda, and that's thrown away afterwards, and any context is lost because you could be writing sensitive data to disk. I've seen clients writing PDF generators on Lambdas where they have a load of data, they run Puppeteer, they open up a browser, they go to some dashboard, they print as PDF, and that writes to disk, such as a temp directory. But if we write into the temp directory, the next invocation, if it comes in on a warm Lambda hit, would have access to that sensitive data. And a mistake in application code could reveal that data, or potentially injected code in an attack could have access to sensitive data written on disk. The key point here is to always remove any file you write to the temp directory in a Lambda, unless you're explicitly doing it for performance optimizations and have considered the security risks. A brute force approach I have seen used, and this code won't be very readable, but it's generally to define a remove folder recursively, basically. Make sure you run it on the right folder, and you run that on the temp directory to clean up after yourself. It's a bit brute force, and it could take away some optimizations, so I see more people going for if we write something, we remove it, and maybe wrapping that writing in their own little SDK with a callback to clean up after themselves. The next key point on securing Lambdas comes more into the architecture of your serverless architecture. So separating Lambdas out. IAM allows us to lock down a lot of permissions with policies and roles. But if we have one large sort of monolithic Lambda function where we've lifted and shifted an application, we're going to have to give it most of the roles it needs anyway. If one request comes in, let's say, to make a payment and it has to access your Stripe token, another request that comes in just to, I don't know, list a set of users, it doesn't need access to that Stripe token, but because we have a monolithic Lambda function that's doing a lot of cross-functional things, it will have a role that lets it do everything. Instead, if we have micro Lambdas that do one thing and do it well and sort of think about separation of concerns, which is always a good principle, we can lock down our permissions and not use one Lambda role for all of our functions, but separate roles with separate policies. To make this a bit visual, we can contrast two architectures here. We have one large monolithic cross-functional Lambda function that basically takes lots of different requests, does routing internally with some traditional sort of web framework like Flask, and then this will need access to lots of permissions. Let's say one of our Lambda functions accesses a super secret database. We'll have to give that one Lambda function that role, but that's okay. Whereas in the other example, we have to give every different request for all different functionalities access to this potentially dangerous role. The key point here is to keep your Lambdas fine-grained with a separation of concerns and apply different roles and policies to your Lambda functions. Building off of this is the idea of least privilege. So IAM, as I said, is a great tool for securing your application, and developers have been massively empowered by serverless, but it does come at a cost. IAM is not the most simple service in the world to understand, and with developers being empowered by IAM, and also with tight deadlines and maybe running in a Scrum team without thinking about the larger security context, they might be applying, let's say, wildcard policies just to get their features in, and that's not cleaned up later, which can lead to potential escalation of policies. We need to use policies that have the specific privileges for whatever's needed to be achieved. Now, it's great to say that, and it's great to train our developers, but we also need to automate this to make sure it happens in a CI level. So the serverless enterprise, serverless framework allows you to do infrastructure as code for serverless applications, works really well with AWS Lambda. The enterprise version comes with dashboards, but it also comes with this idea of policy safeguards. So we can see here we have a couple of failed policies when we've tried to deploy. So no wildcards in IAM statements. It's probably under the hood quite a simple grep, but having these built in infrastructure as code across all your different microservices gives you a sort of peace of mind and also enables developers to be empowered by serverless. Another approach is to audit your policies. So X-Ray is a tool in AWS that allows you to sort of see the different things a request might access across its journey. Now, there's an interesting tool here called AWS Least Privilege, which is a CLI tool that's open source. This allows you to basically run over those X-Ray logs and then generate a policy retrospectively. Now, it's not as good because you have to do it retrospectively, but if you want to go over and do an auditing of your previous functionalities, it's quite useful, and out of that can come training to the people who maybe made those dangerous policies and how they can do better in the future. The key point here is to ensure your IAM policies allow least privilege, train your team, and empower them by making this automatic on CI so they're empowered not to make mistakes. Moving away from permissions, we're going to move to API Gateway. So API Gateway can handle the routing and can link into custom authorizers and different services in AWS before your request hits your Lambda function. Now, it's best not to expose your Lambda functions directly to the public internet. Putting them behind API Gateway allows rate limiting and denial of service protection. Also, integrating with authentication as a service like Cognito allows that authentication to be done quite clearly before you reach your application code. You can also now integrate a WAF with API Gateway, so a web application framework, which allows to sort of first line of defense. This happens before your custom authorizer, before your Lambda function, and actually the AWS hero Yan Xu released an article this morning about API Gateway, DDoS, and security, and that probably has better information that's more up to date than this, but this is definitely a good starting point. The key point here is to not expose your Lambda function to the public internet without going through API Gateway. Also, not every Lambda function needs to be on the public internet. If you have something that's doing some massive exports on a cron job, you don't necessarily need to let people trigger that via an API. That can be done internally and use IAM for protection. Use API Gateway and add a WAF. That can help with blacklisting IP addresses, and also it can scan for SQL injection and XXS attacks. The next point to move on to, which is a classic for security, is observability. Basically know what's going on. Serverless is very flexible and allows this very granular event-driven architecture, which has a lot of power, but it's quite hard to debug when things go wrong. If you have a Lambda function that calls a Lambda function that calls a Lambda function, following that back up can be quite difficult. CloudWatch and X-Ray are a minimum, so CloudWatch is basically automatic, but X-Ray needs a little bit more configuration to track a request through different AWS services. I suggest that the CloudWatch dashboards, although they're great, aren't really built for developers to have great overview of a serverless stack. And I think Lumigo, Espagon, or Thundra are specialized tools by third parties that have a really great user interface to analyze your serverless architecture. They allow you to configure alerts really easily to go onto Slack when there's a problem, and it allows your team to be more engaged with the code they're writing. Also, there's a couple of guys from Thundra and Lumigo here today, so definitely get in touch with them. The basic lesson here is to say that basic logging is a given. X-Ray is also good on top of that, but using a specialized third-party serverless logging visibility platform will help your team be more connected. Also, when you're building serverless applications, you're moving to a more event-driven paradigm. And thinking about recoverability from logs is quite important. If you do have one Lambda function that sends an order confirmation email, if that falls over because your third-party email sender was down, whatever you log out there needs to be recoverable. You need to log the order, you need to log what type of email it was, so you can manually go in and recover from that error. We also need to think about PCI and what we're logging there, but it's quite important to think about recoverability when you're architecting your Lambdas, not just retrospectively when you have a problem. Moving on to some of the final points. So serverless changes a lot about security, but a lot of the common problems still exist. We still need to write secure code, we need to have access controls, we need to do encryption, all the basic stuff. I'm sure a lot of you are familiar with the OWASP top 10, and if you're not, they're definitely worth a read. They're the top 10 vulnerabilities for web applications of the year. And they've recently had a second project, which is serverless top 10 vulnerabilities, which is still a little bit immature, but it's definitely developing. And that's the same principle, but applied to serverless architectures. So keep applying basic principles, work with your teams to make sure they're empowered to know these, and you can add some automated tools like SNCC, which is for dependency securing. It's not particular to serverless, or Protego, which I think they were talking today, is a specialized security platform for serverless applications. I've not used it myself, but it looks really great, and if you're running in production, it's definitely something worth considering. Coming on to some of my final points, account security is super critical and often overlooked. It's super important to separate your AWS accounts. If you have production, run it in a separate AWS account from staging, test, and dev. You don't want anyone to accidentally deploy to production. If you have credentials that have been broken, you don't want to affect production, and you don't want human errors to result in maybe deleting all your databases. Separate them to protect against human error, and separate them to mitigate attacks. AWS Organizations is a great tool for centralizing billing across AWS accounts, and I think you can also share policies as well. One of the pushbacks from companies in separating these accounts is the CFO gets annoyed about the complicated billing coming through. If you use AWS Organizations, that's done automatically for you, and they get one invoice. And one final point, MFA is not optional on cloud accounts. I've seen many clients in the past who haven't had MFA in place, and we train them, but you can automate it. So this is an example of an IAM policy from AWS, and there's a link in the slides here. I will share all these slides online afterwards, but if we highlight a key part here, it's denying access to any resource that's not the key IAM policies that allow you access to reset your password and set up your MFA. So if you enable this on a team without MFA, everyone will be very annoyed for half an hour, but then they'll go and enable MFA to be able to keep working. It's a great way to automate security. So yeah, the key points here, separate your accounts. Production needs to be separate from development, test, and staging. If you want to keep developers all together in one account, I think that's okay. If you want to keep development and staging together, that's kind of okay. But production should not live with development, is the key message. So in conclusion to this, and there's a couple of other side points I want to come on to, serverless takes away some security concerns like patching, for example, of the operating system, but it doesn't take away all of them. There will be new attack vectors, and we need to put in place safeguards to mitigate these. And developer speed and autonomy is great. We're speeding up massively with serverless. We have a lot of freedom, but we need to put in the safeguards and training to allow developers to be empowered and not to make mistakes as we move to developers being more in control of infrastructure. As I mentioned at the start, I am doing some side initiatives around serverless. So I have a serverless blog, which is Serverless Transformation on Medium. Feel free to follow that. I also tweet a lot about serverless. So you're welcome to follow me on Twitter. We have a newsletter that goes out every week with the top 5 articles of the week with some of the context and implications. We now have a podcast, which isn't embedding there, but if you search Serverless Transformation on Spotify, you can listen to interviews and also that serverless newscast each week. And finally, we open sourced a project last week, which is SLS DevTools, which is an NPM dependency. You can install that globally, and basically what it is a dashboard for developers while they code. If you've ever used Chrome DevTools, it's kind of like having that for serverless. Instead of logging into the AWS console, you can, in your terminal, have feedback, metrics, and visibility. Now, this isn't in place of something like Thunder, Lumigo, or Espagon. It's not an online dashboard. It's not for production. It's for developers to get instant feedback without having to log in. You can see a quick example of it here. So it gives you a graph of invocation and errors. You can see all the functions in your stack, the AWS region you're in, the average duration of your last Lambda functions. So as you're developing, if you add a new call to a database, you can instantly see the impact that has on the duration of your Lambda function call. And you also have the logs embedded. It's quite an early release. We're also looking for contributors if anyone's interested. And any feedback would be great. Yeah, I've been Ben. If you have any questions, I'll be around. I'm on Twitter. One of those QR codes goes to the blog. One of them goes to the newsletter. I don't know which is which, so subscribe to both. And if you have any questions, let me know.
Thanks very much, Ben. Okay, have we got any questions? One straight away, great.
So somebody earlier, I can't remember his name, sorry, the guy in the before the coffee break, alluded to the fact that it's very easy if you don't know what you're doing to run up a massive bill. Are you aware of any tools or frameworks or anything that can help either spot or mitigate issues like that?
Yeah, it's something I'm also concerned about, and luckily haven't had too many issues with. You can set alerts on AWS. Definitely having one person responsible for checking the billing and having that in their calendar maybe quite frequently, especially when your team starts to adopt, is very useful. Definitely do load tests before going to full production, and you can sort of correlate. If we add 10 times the amount of requests, it's gone up to this. If we add 100 times, what's it going to be? But no, I don't know any particular tool I would use. Sorry. Yeah, true.
Anyone else? Okay, finishing well ahead of time. Great, okay, we sure? Yeah, looks like a way. Okay, thanks very much. It's brilliant.